So this lecture is on graphing horizontal parabolas. So vertical parabolas are what we're used to. Vertical parabolas either open up or they open down. These either open left if our a is negative and right if our a is positive. These are not in the form y equals ax squared plus bx plus c. These are in the form x equals ay squared plus by plus c. So it has taken all of our x's and replaced them with y's, and taken our y and replaced it with an x. That's in standard form. In vertex form, it looks like this. Instead of having y equals, we have x equals, and instead of having x minus h, we have y minus h. So that's standard form and vertex form. We still have a vertex. However, the equation negative b over 2a doesn't give us the x coordinate, it gives us the y coordinate. So everything is just the opposite of what it usually is. So the first example we're going to do is in standard form. So there's a standard form equation for a horizontal parabola. In standard form, we're going to use our vertex formula to find our y, and then plug our y in to find our x for our vertex. So my a is 1, my b is negative 2, and my c is 3. So when I go to do negative b over 2a, that gives me a positive 2 over 2, which is a positive 1. Now again, that's my y coordinate of my vertex, the second coordinate. So in order to find my x coordinate, I'm going to take that 1 and plug it in everywhere that I see a y. Now I'm going to use my calculator for this. You can just use your normal x button to store it in, or you can use alpha 1 to get a y. So if I press alpha 1, it'll give me a y. So it's up to you which one you use. I'm going to go ahead and use y just for consistency. So I'm going to say 1 stored for alpha 1, which gives me y, and press enter. And then I'm going to type in my equation. So I'm going to say y squared minus 2y plus 3. And that gives me 2. So that is the x coordinate of my vertex. As I go to graph, I plot my vertex first, 2, 1. And now usually for vertical parabolas, we would find other points by using our table function in our calculator. Now the downside to our calculator in this situation is that our calculator will only do y equals. It will not do x equals for us. So I have two solutions for us. The first solution is for us to look right here. Usually that's our y-intercept, but in these it's going to be our x-intercept. So this graph is going to touch at 3 on the x-axis, which means if I use symmetry, then 1, 1, it's going to touch at 3 right there as well. So that's a general shape of my graph. Your other option, one of your other options, is to plug in values for y and see what it gives you for x. So I could plug in 4 for y and see what it gives me for x. So in my calculator, I'm going to do 4 stored for y and press second enter until I get back to my equation. So an x value of 11, which is really far off my graph, so I'd probably only graph these 2 points. But all the way at 11 over here, I'm going to have a y value of 4. If I wanted a y value of 2, so let's see what would get, well, no, let's go even farther. Let's see what a y value of 3 would give me. Maybe that would be a nicer point on our graph. So if I do 3 stored for y, it gives me 6. That's a little bit better. So at 4, 5, 6, I have a y value of 3, which is about where I was going. So just remember, that's something that people forget, even I forget, is when we're picking points and plugging them into here, those are the y points we're plugging in. Whereas usually we're plugging in x points. In these we're plugging in y values because my equation has flipped and there's y's here. So that's something to be careful with. Your other option would be to go to your calculator and go to y equals and plug this in as if it was a y equals, and then your points are just going to be flipped. So if I type this in as x squared minus 2x plus 3 and go to my table of values, I'm going to have the same point. So look, we have the point 2, 1. 2, 1. Everything's just backwards, but your calculator will only do y equals. So if you want to use your calculator, you plug it in as if it was an x equals, but then do your points backwards. Make this your x equals and this your y equals. So see, we have a point at 6, 3, like we just found. So that's how we can use technology for this. It won't do x equals for us, but we can kind of cheat the system, so to speak. So now let's talk about, last thing, domain and range. The domain of these, remember domain runs left to right. So I need to figure out where my graph starts. So it starts right here at 2, and then it goes on to infinity. And the range of horizontal parabolas is always going to be negative infinity to infinity. So again, it's flipped of what it usually is for verticals. All right, now let's do one in vertex form, which is a fairly simpler form to work with. So again, x equals, let's do 2 y minus 1 squared plus 1. Let's make it plus 2 or plus 3. Let's do plus 3. So usually our x value of our vertex is in here and our y value is out here. But again, everything's flipped. So this, if I solve it out, is going to give me my y coordinate. This one's going to be my x coordinate. So my vertex is at 3, 1. My a is positive. Let's make it negative just for the sake of notes. My a is negative, so this is going to open to the left. So if I go to graph this, I'm going to put a point at 3, 1. Again, x, y. I know my graph is going this way. So if I'm going to do this by hand, I might plug in a y value of 2 to see what's going to happen there. Because this, remember, this doesn't give us an intercept like standard form does. So I can either plug in that point by hand. So I would make a table, plug 2 in for y, and see what came out for x. So I would say 2 stored for y. My equation is negative 2 y minus 1 squared plus 3. And it pops out a 1 for my x value. So I have a point at 1, 2, which means symmetrically I have a point at 1, 0 as well. Just like that. Now how can I check that? In the calculator. Well, I can go to y equals. I can treat this as if it was an x, but then just view my points backwards. So look, I have a point at 3, 1. That's my vertex. I have a point at 1, 0. And I have a point at 1, 2. So there's my point at 1, 0. And there's my point at 1, 2. Everything's backwards. I'm going to say that until you're sick of it. So now domain is where it starts. So it starts at 3. And it's going left. So it's going to negative infinity. And my range is always all real numbers. So recap. In standard form, everything's the opposite of y equals, of vertical parabolas. So I'm left to right. This is my x-intercept. And then if I'm going to plug points in or use my calculator's graph, I need to remember it's always backwards. I'm plugging in a y to here to pop out whatever my x is. In vertex form, the number hanging off the end used to be my y. Now it's my x, and whatever's in here is my y. That's my vertex. And then I can either, again, test numbers by hand or use my calculator table and just instead of viewing it xy, left to right, I have to read xy, right to left. Now these, remember we talked about functions in Algebra 1, and we did the vertical line test. So these do not pass the vertical line test. If I was to put a pencil down on these graphs, it would touch more than once, which means horizontal parabolas are not functions. Every x value does not have only one y value. Okay? They are not functions like vertical parabolas are. And again, vertical line test shows me that because it hits more than once. So we're going to be graphing these in both standard form and vertex form. So be on the lookout for a worksheet that will be created by me. So I will be handing those out to you, and these notes will be copied for you as usual. All right, see y'all in class.